So I'm sure you have heard about saturated and unsaturated fats. So to take a time, think about it. Which are healthier, or which are you supposed to eat more of, saturated or unsaturated? Do you know? So the literature and dietitians tell us that unsaturated fats are the ones that are more healthy for us. And saturated are the ones that we should be avoiding or cutting back on at least. So what is the difference? Right? And this is kind of amazing that the difference between a saturated and an unsaturated fat comes down to a very tiny little molecular difference. But that molecular difference then impacts our diet and our health, which is kind of fascinating. So let's talk about what the difference is. So we now know about triglycerides. They're made of a glycerol backbone and 3 fatty acids that are hooked on to create the triglyceride. All right. Now, I think in a previous video, I said that these tails, or the fatty acids that you hook on, they can be different. And so this carbon chain of the fatty acid, this is what we need to focus on here. And here is an example of a saturated portion of a fatty acid. Now, what it means, saturated means like if you're wet through, completely coated, like you can't take on any more, right? So if we look at this carbon chain, the carbons, each carbon atom can make 4 covalent bonds, and they're doing that, 1, 2, 3, 4 in each case. So 2 of them are for making the chain, and then the other bonds have hydrogens. You can't really fit any more hydrogens on here. Every carbon's making 4 bonds, and every bond that's available is taken up by a hydrogen. So it's kind of coated with hydrogen in every possible place. Right. If we look at this example over here, between this carbon and this carbon in the chain, you can see a double bond. Right, so that's okay. Carbon can make a double bond with carbon. But when that happens, this carbon, look, is making 1, 2, 3, 4 bonds. So it's making the correct number of bonds, but it looks like there's a gap here. There's like an H missing. Now, there's not an H missing. There never was an H there. You can't put 5 bonds on a carbon, so there can't ever be an H there. But it makes it look like there's a gap. And so this is what we kind of term unsaturated. It's not like it's coated in hydrogens. So this picture down here, this first one, this is a saturated fatty acid. This is also a saturated fatty acid because you can see there's no double bonds and there's hydrogens everywhere around the chain. But this last one is unsaturated because there's a double bond and therefore there's nothing here and there's nothing here. So this is an unsaturated fatty acid, and when it hooks together to make the triglyceride, this is an unsaturated fat. Whereas a saturated fat would have all 3 of the chains here would have no double bonds and there'd be H's everywhere. So that's how you determine whether a fatty acid and therefore the triglyceride that it's part of is saturated or unsaturated. You're going to look for double bonds in the chain, and you're going to look for whether there's kind of like a gap in the hydrogens like there is here. So that's kind of fascinating, I guess, if you're into that kind of stuff. But why does that make this more healthy than this? Like, what's up with that? Right? So there's lots of reasons for that, but we'll go into a couple here. So here is an example of a unsaturated fat here and a saturated fat at the bottom. Okay. Now the red blobs, this is representing the glycerol backbone of the triglyceride, and these are the fatty acid tails that make up the triglyceride. And every time you put a double bond in a long chain of carbons, it makes the chain kind of kink, zigzag a little bit. So in this saturated fat at the bottom, you can see these chains are pretty nice and linear. The chains are lining up pretty nicely. Here, every time you get a double bond, you get a kink in the chain. So there's a double bond there, kink, double bond there, kink, double bond there, kink. Here there's a double bond, it's making it kinky, right? So now know that the double bonds create a kink in the fatty acid tails of the molecule. Here it goes, that double bond causes bending. So then why is this better for you than this? Because that's what we're saying. If we say that unsaturated fat, which is the top one, is better for you than saturated fat, what's up with that? Well, there's lots going on here, but one of the more simple ways to think about it is if I was going to actually build these molecules for real, like actually physically build them like models, and then I was going to say to you, I want you to pack these in a suitcase. So I'll give you a bunch of saturated fat models and a bunch of unsaturated fat molecule models and say, pack these in a suitcase. Now, depending on how OCD you were, the ones you would probably like to pack would be these ones, right? These ones are going to pack really nicely. They're going to lie together nicely. You're going to get them in a suitcase. It's going to be nice and neat. So if you're kind of like a neat freak, that's going to float your boat, right? So they just pack together better. These do not stack up very well, right? They're all over the place. And so if you think about some of the problems with fats is that it tends to clog or cause issues in your arteries. So your arteries are these tubes that the blood goes through. And if fat gets kind of deposited in and around these arteries, it can start blocking them. That's kind of sort of what happens in a heart attack when arteries get clogged up with too much fat. And so these saturated fat molecules, they do a really good job at packing together and sticking together and packing up to create to start layering around your arteries. Whereas the unsaturated, and because the blood is rushing through those arteries really fast, and so the unsaturated fat molecules, if they stick to the artery, when the blood comes rushing through, they get knocked off much more easily. They can't pack together so well and make a big thick chunk to block the artery. So that's kind of a simplification, but it's sort of a basic mental idea about why these saturated fat molecules are much more likely to cause these blockages in your cardiovascular system. And it also reflects how these fats look at room temperature. At room temperature, saturated fats are generally solid because the molecules compact together and make a solid lump. So butter, lard, all that stuff, that saturated fats tend to be solid at room temperature, whereas unsaturated fats tend to be liquid at room temperature, which is things like canola oil, that kind of stuff. So then, last question, if I was going to send you to the store to bring me back some things that contain unsaturated fat, the healthy kind of fat, what would you bring back? Give you a second to think about that. What contains unsaturated fat? Well, things like olive oil, things like canola oil, things like avocados. What contains saturated fat? Meat, eggs, butter. Okay, so what's the thing that joins these fats up and the things that join these fats up? These are from plants. These are from animals. So animals tend to produce saturated fats. So animal fats tend to be more on the saturated end of the scale. Plants tend to produce unsaturated fats, and they tend to be on the more healthy end of the scale. There are a couple of interesting places where these overlap. So for example, coconut oil, that is one of the most saturated of the plant fats. So while plant fats tend to be on the unsaturated or healthy end of the spectrum, coconut oil is more down towards this type, which is kind of funny because it's the one that everyone is saying, oh, it's super healthy coconut oil. I mean, I don't know. If you're trying to eat unsaturated fat, coconut oil is not the way to go. And you can tell that because coconut oil has a tendency to go solid at room temperature. It behaves more like an animal fat because of its saturated nature. Its tails are more linear. The molecular tails are more linear, so they pack together nicely. Going up the scale from coconut oil, then you get something like olive oil. And olive oil can go solid as well. If you live in cold, it doesn't happen in Arizona. We never see it. But if you've lived anywhere cold, your olive oil in the pantry will sometimes go kind of cloudy and lumpy because it has a degree of saturation to it. It's not completely saturated, but it's on the more saturated end of the plant oil scale. All right, so anyway, so I hope that makes sense. I hope that gives you some information about your diet and fats, and that is saturation and unsaturation in triglycerides.